That's the sound of Voyager 2 as the spacecraft hurtles through magnetic fields on its way to its closest approach to Saturn, 63,000 miles from the cloud tops. And it's sending back pictures of things never seen before. Joining us tonight in Pasadena will be Carl Sagan to help explain the wealth of new information and pictures now coming back. And we'll be discussing the cloudy future of our deep space exploration with White House science advisor Dr. George Keyworth, Senator William Proxmire, and noted science fiction writer and poet Ray Bradbury.
This is ABC News Nightline. Reporting live from the Jet Propulsion Laboratory in Pasadena, California, Ted Koppel.
Good evening. It's there. Voyager 2 has reached Saturn after 4 years in space. It got there just a bit early, 2.7 seconds early to be exact, after a flight of 1.25 billion miles. Voyager's journey began on the fifth smallest planet in our solar system, Earth. 2 years later, it had reached the largest planet, Jupiter. And like any good traveler, it took pictures of never-before-seen moons and huge red spots. Getting to Saturn right on target, less than 63,000 miles above the second largest planet, has been compared to a golfer making a 500-mile putt. But Voyager did it with precision, and its cameras brought beauty to the cold ball of gases surrounded by icy rings, the sixth planet out from our sun. Our guide through the icy rings, strange moons, and storm-whipped planet, astronomer Carl Sagan, is standing by in JPL's Picture Control Center. Carl, tell us about the latest, will you?
Hi, Ted. Well, the latest is that we have just made the closest approach to Saturn. The spacecraft is now recording data, which it will send back to us at a later time. There's a whole suite of observations to be made after we pass Saturn. There are moons that will be observed close up. For example, Enceladus is a moon which in the next few hours we will have the closest approach to. Now, if we want to put this mission in a historical context, we have to imagine our ancestors who looked up at the sky, saw the constellations of distant stars, and then a handful of small objects that wandered with respect to the distant stars. They were called planets. Here is Galileo showing a reluctant clergyman his observations of Jupiter. The development of the telescope permitted us for the first time to see what the planets really were like. Here Galileo saw, well, just a moment ago, we see a Galileo picture of what he thought he saw, a planet with ears. And later, Christian Huygens, a Dutch astronomer, found that the planet was surrounded by a disk which nowhere touched it. The next picture is a ground-based photograph which shows the rings, sort of the best kind of picture before Voyager approached the Saturn system. Today, the best picture is something like this. A picture released today in false color in which we can see some of the thousands of small ringlets which surround the planet, a kind of miniature solar system composed of billions of orbiting chunks of ice in size ranging from glaciers down to particles of smoke.
Carl, let me interrupt with a question that lets me be as ignorant as I am on this subject. You clearly believe, you know that you have made a quantum leap, and you have just taken us through that quantum leap. But why? The pictures don't look all that different.
Well, the picture we just saw, in which there were huge numbers of rings, is quite different from the picture before that, a typical ground-based photograph, which shows maybe 2 or 3 rings. The existence of 1,000 separate rings, which are produced by satellites near and in the rings, we think, is indeed a quantum leap in our understanding. That doesn't mean we understand why the rings have the configuration they do. But when all that is pieced together, we will understand how a central mass with a flat disk around it works. That's of importance because when the solar system formed, There was a central mass, the sun, with a flat disk, the solar nebula, which later became the planets. But also it's an important testing ground for our understanding of the galaxy. The whole Milky Way, a collection of hundreds of billions of stars, has a central mass, the core of the galaxy, and a flat disk, the spiral arms. So we have in our backyard a natural laboratory for learning about the origin of the solar system and the nature of the galaxy in which we inhabit. It's a remarkable accomplishment.
All right, Carl, quite literally, during this period of hours, couple of hours now, Voyager is coming, has come as close to Saturn as it ever will, and as perhaps any other spacecraft will for many years to come.
Well, I hope not, but you may be right.
All right. What of the pictures that are coming in right now? What of the newest? What are you finding even in these couple of hours?
Well, here's a sampling of some of the recent pictures, just to give a kind of feel of where we are. For example, if we look at this picture, we see one of the successful searches for new satellites. There are some 10 or 12 new moons of Saturn, which have either been discovered by Voyager or discovered during the period of the Voyager encounter by ground-based telescopes. We've more than doubled the number of moons that we know about on Saturn. Here is Enceladus, a remarkable world which has the density of ice. The whole place is one solid lump of ice.
What is it, Carl, related to Saturn? It's one of Saturn's moons?
It's one of Saturn's moons. It's one of the closer in, the second closest of the large moons. And in the outer solar system, because the temperatures are so low, ice is very stable. This is an enormous snowball, hundreds of miles across, the size of a world. And we can faintly see impact craters, which have probably melted the ground when they hit and deform and disappear. It is a world totally different from anything we've seen before.
Are those four black dots somehow marking dots?
Yeah, those are fiducial markers on the television screen, and not markings put on Enceladus. Not as interesting as if they were on Enceladus. In fact, you'll see in many of the pictures those fiducial markings called rissoes. Here is a lovely image of Titan, backlit by the sun, which is off to the left, and you can see the ring around it, which represents light which has been refracted through the atmosphere of Titan, an atmosphere filled with organic molecules that are raining down on the surface, a surface that we have never seen. To understand the nature of that surface, probably loaded with hundreds of meter column of organic molecules, will require some other mission in some other epoch.
When did these pictures come in, Carl? All within the past hour or so?
No, these are within the last 12 hours or so, as we zip through a wide range of moons and, of course, the rings and Saturn itself. Here is a view of an astonishing icy kind of moon called Tethys. You can see this enormous valley, which runs essentially half the length of the object, which has been called Ithaca Chasma. And here you can faintly see in middle left a vast impact basin which was discovered late last night. And here in lower right you can see that basin, which has multiple rings and looks like some of the Maria on the moon.
What is the assumption, Carl, as far as those impact basins are concerned, that it was caused by what? Meteors?
Well, the outer solar system is filled, Ted, with junk, debris, things the size of a house to the size of a small moon. And occasionally there are collisions. Because the solar system is 4.5 billion years old, wait around long enough and you're bound to get a collision. Most of the impact craters we see are due to collisions made in the earliest history of the solar system, before most of the debris was swept up by such collisions.
All right, before we run out of time, show us what else you have.
Well, that's essentially all I wanted to show you about the latest pictures. Enceladus, that icy fellow, is something which we will have much better pictures of shortly. But what I wanted to say was, think of the remarkable achievement. For 4.5 billion years, things fall on the Earth like those impacting meteorites. Nothing leaves it. Suddenly, in the last 20 years, a set of tiny golden spacecraft go off in all directions to examine every one of those ancient points of light that our ancestors called planets. For the first time in human history, we have examined close up these other objects and discovered them to be worlds awaiting future exploration.
All right, Carl, let me nevertheless ask an irreverent question that I
Please.
suspect some people out there are asking right now. So what?
Well, let me, can I spend a minute or two on the so what?
Try the minute.
Okay. Here's what I would say. A, human beings are in the exploring business. That's what we're good at. We enjoy the sense of exploring something new, and it has adaptive and survival value. Second, exploring the solar system gives us other worlds to compare our own with, to better understand and control our own planet. Third, there is a pumping of high technology, for example in robotics, which has applications to many other practical aspects of life on this planet. Fourth, we are exploring the deepest questions that every human culture has asked, questions of origins. In this case, where did the Earth come from? Where does the solar system come from? Where do we come from? And finally, it is an enterprise which is peaceful, which is on behalf of the entire human community, and which will be remembered for thousands of years. It is by far a bigger step than Columbus's discovery of America. The exodus of human beings and their robot emissaries to explore their local swimming hole in space.
Carl Sagan, we will be back with you on the special expanded edition of Nightline for a look at the very latest pictures which are still coming in and which will continue to come in for some time. When we return now, Jules Bergman takes a look at the long road that led to Voyager 2, a road which may soon be ending. Not the money, no more pictures or scientific data after Voyager 2. ABC Science Editor Jules Bergman covered the beginning of America's unmanned journey into space, the year 1964.
Ranger 7, America's 5th attempt to get close-up pictures of the moon, a complex mission that has failed every time it's been tried. The pictures vital before men can land on the moon. And here's the way it went today.
5, 4, holding momentarily. 3, 2, 1, 0, liftoff, test 448.
4, 5, 6, 7, 8, 9, 10 seconds.
Ranger 7, off to a good start, but it's a 68-hour flight with 24 critical steps before its cameras ever attempt to send back man's first close-up pictures of the moon. Jules Bergman, ABC at Cape Kennedy.
That was the beginning, the first successful Ranger mission to the moon. What followed was nearly 2 decades of exploration, discovery, and excitement. More than 50 missions. And we still remember the names. Surveyor, 7 missions between 1966 and 1968. Moonlanders that scooped up and examined the lunar soil. Lunar Orbiter, 5 missions during that same time. We mapped the moon and saw for the first time its hidden far side. The moon was our most important goal back then. To send man there, we had to know what it was like and whether or not its surface could support a spacecraft. Years later, the astronauts of Apollo 12, Pete Conrad and Alan Bean, landed their lunar module Intrepid just 600 feet from one of those early missions, Surveyor 3.
Oh, you'll never believe it. That's what I see sitting on the side of the crater. The old Surveyor, huh? The old Surveyor, yes, sir. It's a beautiful sight to see Intrepid and Surveyor sitting here on this crater.
But the moon was not our only target, so we launched 10 Mariner spacecraft between 1962 and 1973. Mariner's cameras showed us for the first time the rugged and barren surface of Mercury, views of superheated Venus, the heat held in by the mysterious blanket of clouds. And we learned for the first time that Mars didn't have canals, but rather craters and enormous mountains. We still weren't satisfied, though, and we sent Viking, which landed on Mars in 1976, a spacecraft right on the surface which analyzed its soil and atmosphere and sent back the first close-up glimpses of another world. But we don't know what we're actually going to see, whether the surface will look like this Earth sand.
Whether it'll be sandy, rocky, lumpy, ripply, or any other thing, we have no way to know. That's the whole excitement of exploratory ventures of this sort. There's no telling what we will find.
Here's what appears to be the first picture coming in, Carl.
Can I go take a look?
Yes, let's. But there was more to do and more to see, and 17 Pioneer missions were launched between 1958 and 1978, 2 of them to Jupiter, and finally Voyagers 1 and 2, closer to Jupiter and her moons, discovering and photographing active volcanoes on one of them, Io, and then on to Saturn and the 1,000 or so rings around it. But Voyager is the last of the picture shows from space for a very long time. The excitement of the early missions may never happen again.
Pictures look good. Each picture jumps you closer to the surface. We've impacted.
Memories of those missions from the last 20 years are most vivid here at the Jet Propulsion Laboratory, control center for most of our planetary space flights. But memories may soon be all that's left. Unless more money is found, the era of reaching out to the planets, of sending our spacecraft and landers to other worlds, will all be over. It will be 5 years before we see pictures from deep space again. The same Voyager spacecraft that's now sending back photos of Saturn will continue on to the planet Uranus and get there in 1986. After that, 3 more years, and Voyager will reach Neptune in 1989. There is only one new mission left on the drawing boards. It's called Galileo, running behind schedule already and working on a tight and possibly inadequate budget. The goal is Jupiter, an orbiter to circle that enormous planet, and a probe to plunge into its atmosphere. Arrival there not before 1987 or 88 at the earliest. In fact, it looks like the U.S. is even going to miss what promises to be one of the most spectacular space expeditions ever, chasing and catching the most famous of all the comets, Halley's Comet. It will pass near the sun again in 1986. The Soviet Union, France, Japan, and possibly other nations are all planning missions to observe it, but not the United States. NASA just can't get the money. It's a bitter disappointment for the scientists here at JPL, especially Director Bruce Murray.
Halley's Comet is the most exciting object to explore that we haven't yet explored. It's a natural thing to do, and we would have had a very good mission underway. I would be able to show you the spacecraft under development normally, since we're now only about 4 years away from launching that. The reason it didn't happen was while these big delays were going on with Galileo and other programs because of the shuttle and other launch vehicle problems, nothing else could get started. And the national consciousness was broken. We were worried about other problems. And so we let this opportunity, literally of a century, slip by. We can get a glorious and terribly important scientific information on the whole coma and the process going out. We can even bring back some of the molecules that make up that comet, or atoms. We can collect. We have a technique worked out where we could actually bring some of it back, believe it or not. We can do those things if we but try. And we can do them confidently without straining our national economy, without even straining our space technology. And for us not to do it is a negative act. If we couldn't do it, or we were just equal to them in our capability, that's another matter. Then you might be right. But when we can do it so much better and complement and make Earth's response to Halley's Comet such a more meaningful thing, for us to walk away from that, we are telling ourselves, as well as everybody else, that the past 20 years are the past, and the future is a different kind of world, and that we do not feel the desire, perhaps even the courage, to want to lead anymore.
JPL will most likely survive. There will be some layoffs, but according to Murray, the lab will do a lot more work for the Department of Defense. But it's more than the future of the Jet Propulsion Laboratory, says Murray.
I think it's
the future of a nation.
What's happening with Voyager is not a narrow activity for the group of scientists that are there. The scientists are the agents for society. We're all exploring together. We're creating new knowledge. We're influencing the minds of human beings all over the world through television and other means. That's a national cultural process. And that's the result of decisions that were taken in the late 60s and commitments that were kept alive in the 70s. And we are really at the crossroads as a nation of whether we want to lead in this important human endeavor. If we want our legacy to be knowledge and discovery and widespread public approval all over the world of our activities, or not.
5, 4, holding momentarily.
How long will that hold be? We'll be back in a moment to discuss that with the President's science advisor, the head of the Jet Propulsion Laboratory, a U.S. Senator, and a noted science fiction writer. Exploration. Will the funds be there when they're ready to continue exploration of our solar system? Those are a couple of the questions. We hope to get the answers from President Reagan's science advisor, Dr. George Keyworth in Boston, Senator William Proxmire joining the discussion from Green Bay, Wisconsin, and with us here in Pasadena, Bruce Murray, director of the Jet Propulsion Lab, and also at the Planet Fest exposition, science fiction master Ray Bradbury. But I would like to turn first of all to Dr. Keyworth. Dr. Keyworth, you heard Mr. Murray raise the question a moment ago, and that is, will the United States still have the courage to lead in this area? I realize it's a loaded question, but try it on for size anyway.
Well, Ted, like most of America, the administration, the Reagan administration, is full of space enthusiasts. We are ushering in a new generation of space science capability with the shuttle. We've picked the fruit that are closest to the ground with our planetary program over the last 15 or more years. And I look forward to a continuing rich program in planetary science, planetary exploration. Granted, the missions will be farther apart, but they'll be much more complex, and the amount of data that they will bring in is far greater than what we're used to. In addition, we seem to be missing the fact that in just a few years, an immensely exciting new breakthrough in astronomy, not in planetary exploration, but in astronomy, will be launched, the so-called Space Telescope, called by many, including myself, perhaps the greatest advance in astronomy since Galileo's first telescope.
All right, forgive me, Dr. Keyworth. What I hear is a very seductive siren song, but I'm not really getting a direct answer to my question. The question is, really, will the money be there in order for the United States to continue leading in this area?
I believe so. I believe so. If you mean will our space program see multiplying in its budget, I think that's very unlikely. I think with a budget of the magnitude of the present one, I think we can continue to be leaders in space, and I feel confident that we will do so.
All right, we're going to go on to our other guests in a moment, but I have to ask you about Halley's Comet. You heard Dr. Murray make an impassioned plea for that project a moment ago. Why isn't the money there for that?
Well, I sympathize with Bruce, but it's a matter of priorities. The Galileo mission was chosen by the scientific community as being of higher priority than the Halley's mission. Now, we still have some options with Halley's, and we're still pursuing them. It could become part of the Galileo mission. He hit on an essential point, and that is that the real nut of the possible experimental program to analyze Halley's would be to bring back some molecules. And that is not an easy experiment. It could be done, but it would be extremely expensive.
All right, Senator Proxmire, you are surrounded here quite clearly by space enthusiasts, but I'm wondering whether you will play the role of the heavy for us. Is this a Golden Fleece Award? Is this
no, it's not a Golden Fleece Award, Ted. I think it is a program, however, that should be treated like every other program. After all, we've been thrilled by space, we've been excited, we've been proud of our great achievements in space, but it's time that we recognize that space has to make the same painful sacrifices we're making everywhere else. I spent today on a dairy farm. The dairy farmers are going to be hit hard by this Reagan budget. Others are going to be hit hard by it. Those sacrifices should be shared by the space community. What we should do, for example, is have the Defense Department pay, which they don't pay in full, for the use of the shuttle. They're being charged about 7% of the cost of the shuttle. NASA picks up 93% for the time the shuttle is used by the space program.
Are we not talking here about just robbing from Peter to pay Paul, taking it out of one pocket and stuffing it in another? It's all got to come out of the same budget eventually.
No. You see, the trouble is that the Defense Department will go ahead with the shuttle, using the shuttle when they get it at bargain rates. If they had to pay for it, they'd probably want one orbiter instead of two. They would probably also consider expendables much more carefully than they are. And I think they'd be much more likely to have an efficient program that would get the most military dollar out of it. Then in addition to that, I think we ought to take a look at proceeding only with other programs on two bases. Number one, we ought to do our best to try to get cooperation from other countries. After all, the other countries have the same stake we have. As Dr. Sagan said in his beautiful statement, the entire human community benefits from this. The solar polar mission is an excellent example of how we should proceed. To get other countries involved, other countries are paying about a third of the cost of that. We haven't done that in most of these programs. We should insist on doing it. And finally...
forgive me, go ahead. You've got a final point.
Well, the final point is that we should do as much as we can with Earth applications and see that industry pays their share. After all, if industry is going to benefit from these programs, they ought to pay for it. And a good test of whether the program will work is whether they will pay for it.
All right, Bruce Murray is standing by. You're the director of JPL. Senator Proxmire has made some excellent points, not the least of them being, why shouldn't you be subjected to the same cost-cutting, budget-cutting that every other aspect of American society is? Except, I suppose I should add parenthetically, the Defense Department. And there's another good point he's raised.
Well, I think the fact of the matter is that NASA has been giving its share. I think it's been treated a little better than average because it drives technology for the whole country, and that improves our strength industrially for a lot of other purposes. I think the kernel of the issue for planetary exploration, however, is it is a visible national leadership activity. It's peaceful, it has virtually no negative side effects, and there's probably nothing else at this point in the history of our country that is the hallmark of greatness among nations than what is happening with Voyager tonight. And so I think the issue remains as to whether we think we can afford to be great.
All right, but that raises once again the point that Senator Proxmire broached a moment ago, and that is the issue of whether this should be a nationalistic kind of project, or should it and can it be something that can be done in cooperation with other countries?
We do a good deal of cooperation, but the fact of the matter is if you want to lead, you have to lead. You have to step out in front, you have to set the agenda, you have to make the opportunities. If we all sit around and negotiate about it, we can have an International Geophysical Year, but we won't have the U.S. leading in space. It really is a matter of U.S. leadership, which we now have, and whether or not we choose to keep it.
All right, the scientists do it. It is men of vision like Ray Bradbury who sometimes bring it to life for the vast public out there. And Ray Bradbury, you've been doing it for many, many years. Give us your vision of what lies ahead and perhaps what ought to lie ahead.
Well, I feel that we, as human beings on the earth, should consider our position. We have a feeling of responsibility toward the gift of life in the universe. And I was tempted, in fact, 2 years ago, when Pope John Paul II came to America, I wanted to send him a cable and say to him, meet me at Cape Canaveral on Easter morning, and we'll invite all the rabbis of the world and the Mormon Tabernacle Choir to come there to celebrate a Mass with us for our movement into space. Because I believe that it is our destination to move into space as human beings and to try to do something with this very special gift that we have.
Ray, you know that some people would consider that more than just a little bit irreverent. You really feel that strongly about it? You feel it is man's destiny to move into space?
Yes, because we've been given this gift for some special reason. We don't know. The greatest scientists in the world cannot tell us at this moment what life is all about. The greatest religionists cannot tell us what it is all about. So blindly we reach into space and say, if the sun should die, if the snow should fall, if we are frozen deep in time, or if the sun should explode and we are destroyed forever, does that mean that our light blinks out with Shakespeare or any of the other great people that we wish to speak of? I don't believe we want that. I believe we think we are that special and that precious and that wondrous that with all of our